Hello everyone, welcome to Python and AI Engineering for .NET Developer series. Today in lesson 7, let's start to learn about the object-oriented programming in Python. So in the previous lecture, we talked about the data classes and what's the use of data classes, how data classes used to hold the data, and we had brief idea about the classes. So let's start with the detail into the class, how to define the let's say interfaces, or how to define a contract, and get into more detail into the object oriented programming in Python. So now let's start with a simple class, right? So just like C# classes, we can define a class in Python. On the left hand side we see the example of the C# class, on the right hand side we see example of a Python class. So there are some let's say we need to understand some conventions are there. For example, how do you define a constructor in a .NET, like a public class name with a parameter? Similarly, when you define a constructor in a Python, we will use this underscore init and then the parameter. So in Python, we need to remember each method, each let's say the be it constructor, any other method that accept one parameter called self, which is like a object, which will be reference to the current object. Now let's say .NET we define attributes like class level variables. Similarly in Python we need to define using the self dot and the name of the attribute and the value from the constructor. So this is how we define the attribute for a specific class. Now in the .NET we have these properties where we define any is something similar to the let's say fields, but it may have a getter setter method. Similarly in Python we can define any function as a property, and whenever we want to access this particular function or particular property, we can just use it like a class object dot request underscore count. We don't have to call it like a method. So what is the key difference that we see? Again, we saw the same thing in the previous lecture in the data classes, but again to reiterate, in the C#, in the instance references are using this keyword. In Python they are using the self keyword. Now in C# we have, let's say, various private, public, let's say encapsulation methods are there, or specifiers are there. But in Python there are no such thing. Every method is by default public, but we define a convention where any method name starts with an underscore that is being identified as an internal use, right? Now similarly in the properties in a C# we have the getter setter, but in Python any method with an decorator property will be considered as a property. Again, constructor in the C# is a class name with some parameter, and in the Python it's a underscore init. Now interfaces will go into a bit more detail, but before going further, let's jump back to Visual Studio. We'll look into a simple class, how do we define the classes, and then we go for the interfaces. Okay. So now let's say we'll come to the Visual Studio and we see how do we define a classes. So I have created several methods, several already class files here for day 7. And again we have something called AI underscore clients. So that's the first example where I want to define various classes. Now here I am using the data classes, the enum, these two we have learned in the previous lecture. So if you want to reiterate, I'll suggest you go back to the lesson 6 where we talk about the data classes. So there we see how to use the data class and the enum. Just have a quick recap. Data classes is kind of a similar to a class, but it will just hold the data, and all the boilerplate methods like init, string, representation we don't have to define in case of a data classes. So if you define, let's say, AI config as a data classes with certain properties like a API key, model and base URL, we can just define it like that. But in case of a class, then we have to define it within the init constructor using the self dot and the property name or the attribute name. So here I am going to create one LLM client class, or called AI client, which is a simple class. Here I've defined a init constructor, and in constructor the accept several parameter, and some of the all the parameter I've defined and created as a class level variables. Then I define a method which actually triggers the request of let's say LLM request, get the response and print. Now just to use this particular AI client, I've created several data classes like our AI config, and here I mark frozen equal to true so that this is immutable. Similarly, I define one enum type called center type, and I define certain data classes like AI prompt, AI request, AI response. Now how to use this particular class, right? So if I go back to app.py, so here I have created a config object. Then I created a AI client object where I passed the some name and the constructor parameter, and I passed the config, and I pass some variable, let's say save conversation, so that it can go, or it can iterate, it can remember the previous conversation true or false. So now let's run this app.py, which is the AI client, to see the response. So okay, so let's start. I'm already in the AI developer series, so let me go back to the day 7. Okay, and the day 7 will start the Python, then app.py. Okay, so now it will ask for a prompt. If I just go to the code, so I'm looping through a while loop, and I ask for a user input, and based on the user input, if it is not exit or reset, I'll continue calling the let's say AI request object, create a AI request object, and then call the client, AI client send message, right? So let's say I want to talk about country India. Okay, so once you send a response request, it will talk about some information from the AI, return, let's say what is the capital of India, and also I print out how many tokens has been used. Let's say I want to add any questions related to my previous responses, and if you see it here, I have marked as continue if I have marked as save conversation as true. I'll go through this how I am doing it, but when the save conversation is true, AI will remember the previous conversation. So if I just ask, let's say population, so then it will understand I'm asking about the country India, and it will give me the population. But here we see one thing, right? We have asked one single question, but how many tokens has been used already, right? So altogether 116 token has been used. So just to give us one example, I'll just say reset, and if I go to the reset, it will reset the conversation. Now let me ask another question, which is again population of India. Okay, so now if I ask this particular question, now we see the token use is comparatively very less, right? So now in this previous cases, it was remembering the previous history, so it actually use all the token accumulative, so the total token count use consume is higher, but in this case total token count is reduced because I'm just resetted the conversation. Okay, so now let's go back to AI client, and just to see how the conversations are being used, because again we are using this lesson for AI learning. So in the AI response request has a parameter called previous response ID. So if let's say self dot previous response ID, if it is having any value, then I'm setting the value as part of the AI request. So whenever I pass a previous response ID to AI request, it actually remember the previous conversations and give me a response which respect to my all the previous conversation. Okay. So now this is how we can define a class, we can define the data classes, what are the different use of the classes and data classes, how can we create an object of a class, how can we use this object to make any call to the respective method. Now let's go back to PowerPoint and go to the next topic. Next topic I just discussed now. How do we create a AI client wrapper? How can you define various methods, properties, or various let's say parameter, the data classes. I'll upload all the files and the let's say examples to the TechWayFit blog. So make sure to visit the TechWayFit blog and download the code examples. Okay, so now let's go to the next topic for today is the inheritance and the abstract base classes. So when we are in a .NET world, we know how can you define an interface using, let's say, public interface and with a convention I starting with I and name of the interface. For example, here we have the LLM client as an interface, and we have an OpenAI client which actually inherit from this particular interface, or we can say implement the interface and define the method that is defined within the interface. Now when you come back to Python, so this is called a base class. Python don't have a direct concept for interfaces, but it implements similar method using a base class. Okay, so now for that one it uses a package called ABC. Again, ABC stand for a base class, and from that package is imported the ABC and the abstract method, this decorator and this particular function, right? So now any class, if I want to define as an interface, I need to inherit from the ABC class. Okay, so let's say I define one base LLM client inheriting from the ABC class, then I can define any abstract methods that is part of the particular interface. Okay, so let's say here I define two abstract method which is called complete and usage report. Now here the triple dot simply means this is a valid method but without any implementation. We can also type pass, so both works in the same way. So now we can also a interface or a base class in Python can have a abstract methods as well as any concurrent method that we can define it here. Now if I want to create a specific implementation, let's say OpenAI client, I can just inherit from the base client, then I can implement the method complete and the usage report, then I can use OpenAI client instead of wherever I need a base LLM client. Okay, now moving on to the next part. While before we go for the code example, so we need to remember in Python the uses of ABC is again not enforced. That means I can just define a class called OpenAI client and let's say local LLM client, and both has the same method called complete. And if I have another method that actually pass a client object and call the complete method passing this particular text as a parameter, and if I pass object of both the different classes, one is OpenAI client and local LLM, so in this both the cases it will not throw the exception because both the classes has a complete method with a property with a parameter called prompt, so it will compile fine and run fine. So if I pass let's say any other method, let's say any other object which do not have the complete method, then at the run time it will throw an exception. But if I define using ABC as a abstract classes and abstract method, in those cases during compile time it will throw an error. For example, we have a class that inherit from the base LLM client, but it does not implement the complete method, then it will throw an error whenever I want to create a object of type broken. Right, so that's how we can be very sure and how to use the abstract classes or interfaces in case of a Python. So now let's go back to Visual Studio and then we'll see some examples how can we create interfaces and the base classes and how can you create different implementation. So now coming back to Visual Studio, I have created LLM clients as a file where I've defined one base class or interface called LLM client base, which actually inherit from the ABC base class, and then I've defined one abstract method called send request. Now I created three subclasses or implementation of this LLM client base. One is OpenAI client, one is Anthropic client, and one is, let's say, Azure OpenAI client. Again, I have just simulated the send method by waiting for 2 seconds, but in this way we can simulate the behavior and check the response. But the main concept here is this all interfaces, let's say these all child classes, OpenAI client, Anthropic client, inherit from the parent class and then implement the abstract method send request, so that I can use OpenAI client instead of the LLM client base wherever required. So let's create one LLM manager, and then LLM manager, what it does, right? So we'll go through what are the class method, static method, but it will have one request object called, one method called send request. Then it will identify the current client based on the name, and then it will execute the same client send request method. So if I want to just say get the client based on OpenAI as a name, again here I am using the LLM manager LLM client method. In the LLM client method, I have written a simple provider where based on the name of the client, you will just create the interface, the respective implementation, and then it can call the respective method as required. So here OpenAI, it will call the OpenAI method, and similarly if I want to pass, let's say, Anthropic or Azure API, then it will call those methods. Now before we go ahead and print the response, I want you to understand three different methods that a class can have. Now, okay, let's see. Okay, so first method is called a class method. Second method is called a static method, and third method is without by default, which is called instance method, right? So okay, let's start with the class method. So when defines a method as a class method, then that particular method is available at the class level. That means all the instance of this particular class, they can have access to the same method. Again, we can define any class level variable. For example, here I have defined clients. I have not defined it as a self.clients. So it is not available for instance, but this is a class level variable which would be shared across all the object of the specific class. So if I compare this with a standard .NET, so this is kind of a static property and static methods within a specific class, which has access to the property, and the same property will be available to all the instances of this particular class. Now, second method type is called static method. So while I told class method works like a static method in a .NET, then usually the static method is just a placeholder method in a class. That means it does not accept any self or a class as a parameter. Like class type method will accept class as a parameter, then using the class variable it can access the class level properties. But static method, they don't accept any instance or the class level parameter. This is purely input and output based methods, and they just need to be packaged within the particular class because this might be relevant to the class. So that's what the static method is. It does not have access to the class level variable or the instance level variable. Third thing, by default, if I define any method, so those things would be instance method. So instance method can have access to the instance level variable, and it can have access to the class level variable and the class level method. Okay. So now whatever I have done it here, I have use a class level method to register three different instance of three different let's say LLM client object, and then those things are stored in a class level variable called clients. So if I just go to the register LLM client method, it actually use the class level client variable to store the particular client against those particular name as a dictionary object, and then I can use whichever client I want, local LLM manager, and pass whatever the value I want, and it create an instance of the particular in the, let's say LLM type, and call the respective send request method. So now let me run this particular example. Also here you see I have used if name equal to main. So again, this one we have discussed in our session 2 when we talk about, let's say, the packages and how can you test a method within a specific file without calling without calling it from a outside another entry method, is using the underscore name equal to main. Name is always when whichever calling method is there, and main means if I call this particular method directly as a Python executable, then the name would be main. So let's say I'll first exit the previous one, and let's start and let's run this LLM client. So Python will have the LLM clients. When I call the LLM clients directly, the underscore name would be main, so it will execute all the code. Okay, so now so if I now call this particular method, we see for the first response it uses this class level method. Sorry, this is the static method LLM client, where it can, based on the type of the LLM client, it can get the respective object and execute the send request. Similarly, on the below examples, I created 3 objects of respective let's say LLM type, OpenAI, Anthropic, or the Azure OpenAI, and using the object I call the method, which internally identify whichever object or whichever subclass it needs to call, and it call the respective method. So that's how we can define a interfaces, we can define a base class, or we can have some default implementation in a base class. We can define different method type, let's say the class method, static method, instance method, and use them as needed. Okay, now let's go back to the PowerPoint. Okay, so next thing, again we have seen this particular example. We can define one base class, and then we can define any implementation as we want, and whenever we call this implementation, it will go to the respective implementation and call the overridden method. Okay, so with this one also we have discussed the class method and the static method. How can you define a class method, how can you define a static method using the decorator class method or using a decorator static method. Now just to understand what we have learned as part of today's lesson, key takeaway. So first thing is, whenever we define a class, we define it in a similar way both in C# and Python using class keyword. And then to access the current object, in Python we use self, in the C# we use this. Similarly, in Python, we use convention when any property or method where name starts with an underscore. This is being considered as for internal use, but in the C# we use the private method or the private specifier, so that we can define a particular method as a private method or a public method. Then for Python, we use property decorator to define any method as a property, but in C# we use the getter and setter. Now in Python we use ABC package or ABC inheriting from the ABC class, defined as an interface or an abstract class. Then it can have an abstract method. In the C# we have interface, and C# also we have similarly abstract methods. Now in Python we have 2 specific type of method called class method or static method. The class method is like a static in C#, which can define a static class level variable, class level method, which can be shared across all the instance of the particular class, or a static method which is just input output without having access to any class level variable. Now we also talk about the doc typing, where we can call a specific we can pass a specific method and call the respective, so you can pass a specific object and call a method, and Python will not throw example, but it will execute as long as Python finds the respective class with the respective method with the exact same signature. Okay, so that's all for today's lesson. In the next lesson, we'll talk about the functional aspect of the Python, how Python consider function, what are the lambdas, and we have talked about various decorator like abstract method, property, class method. So we'll learn about more on the decorator, how can we define our own custom decorator. So yeah, so stay tuned for the next lecture. So again, all the examples that we went through, I'll upload everything to my techwebfeed.com blogging website. Feel free to visit there and download the packages so you can practice them. Everything we covered today, including the scripts, configuration, and extended documentation, is available right now on techwebfeed.com. While you are there, check out our deep dives into enterprise security and design principles, or put your skills to test with our developer focused quizzes. Hit subscribe to stay in the loop, and I'll see you in the next lesson.